Hello guys, welcome to my channel. Today's topic is continuity and discontinuity. When a function is not continuous at a point, it has discontinuity. And there are four types: removable, infinite, finite, and oscillating.
Okay, so removable discontinuity is when you have a graph, where you have a function and then you factorize, and when they cancel, they make a hole, which on the graph you put as x equals minus 4. So 1, 2, 3, 4. Here is a hole. So here the graph doesn't continue, that's why it's removable, because you take it out of the function. Infinite discontinuity is another type, and this is when you have a function and then you equalize x equals 4, so 4 is your asymptote, your vertical asymptote, and you graph it, and when you x approach from the right, it's positive infinite, and when x approach from left, negative infinite. So that's why it's a discontinuity, because they don't cross, so each one goes to different places, so here the limit does not exist.
In mixed discontinuities, we have, for example, this graph. And as we can see, the function has an infinite discontinuity right here in the left side, but in the right side we have also a discontinuity in number 2, which is removable. And since there's more than one reason why this discontinuity exists, we can say that it's a mixed discontinuity. In endpoint discontinuities, we have a function which is defined on an interval with a closed endpoint. For example, here 0, positive infinite, being 0 the closed endpoint. And the limit cannot exist at that specific endpoint. And here we can see that x doesn't approaches from both sides, which means that it is discontinuous. And finally we have the oscillating discontinuity, when the values of the function appear to be approaching 2 or more than 2 values. The most common example is this one right here. Fx equals sin 1 over x. And as we can see, these values seem to be approaching several values. And this means that the discontinuity is x equals 0. And another example is this one. Fx equals cos 2 pi over x. And as well, we can see they're approaching several more values.